Welcome, I'm Emily Bushnell, nursing instructor at Vincennes University. In this video, we'll be talking about the circulation and perfusion of the heart and the body, along with the cardiac cycle. In order to understand circulation and perfusion, we first have to understand how the blood moves through the heart, how it connects to the lungs, and how that connects to the circulation in the rest of the body. So blood has to move through the heart and the lungs in order to receive oxygen to deliver it to the rest of the tissues of the body. So let's talk about your heart first. Your heart has 4 chambers. The top 2 chambers are your left and right atria. Your bottom 2 chambers are your left and right ventricle. When you listen to a heart with a stethoscope, the sound that you're hearing is actually the valves closing. We always want those valves to close very tightly and for the blood to always be moving forward. Any backflow of blood can lead to heart murmurs and clots, so we always want the blood to be moving in a forward direction. The cycle begins in the right atria. It begins with the superior and inferior vena cava, which are the largest veins in the body. They dump blood into that right atria, and that blood is deoxygenated. While that's happening, your left atria is filling with oxygenated blood from your lungs. An important thing to note is that veins always carry blood back to the heart, and arteries always carry blood away from the heart. When your atria are full, they're relaxed and they're filling and they're full, they're going to contract. The force of that contraction is going to open up the 2 valves in between the atria and the ventricles. Those are your mitral and your tricuspid valves. The force of the blood being pumped from the atria opens the valves and allows the ventricles to fill. While the ventricles are filling, that pressure rises until it gets to a point where the ventricles are going to contract. At that point, those valves want to close up because we always want forward motion of the blood. When the valves close, then the ventricles are able to pump their blood, so that your right and left ventricle always pump together. When they pump blood, the right ventricle pumps the blood to the lungs through the pulmonary artery, and your left ventricle pumps the blood out the aortic valve through the aorta to the rest of the circulation and the body. The heart and the lungs are married. It's very important that we have both organs working together. When blood is pumped from that right atria through the pulmonary artery, it goes to the lungs. And as it gets to the lungs, it's carrying deoxygenated blood. That blood is full of waste products, it's full of CO2 and different things that we want the lungs to exhale from the body. So the blood moves in between the lungs, it drops off that deoxygenated blood, and when we breathe in, it picks that oxygen supply back up into the blood, and the blood moves on its merry way back to the heart. It gets back to the heart through the pulmonary veins, and those veins connect to the left atria. So now we're on the left side of the heart. So we're back to the beginning of that cycle when the atria are filling, except we're on the left side. So the atria fill, they pump, they contract down through that tricuspid and mitral valve, and now we're into the left ventricle. Those ventricles are the powerhouse, especially that left ventricle. It is the largest muscular part of the heart because it has to overcome a great force in order to supply the rest of the body with blood. So those ventricles are going to contract and they're going to empty fully. The other valves are going to close. That blood is then pumped out through the aorta to the rest of the body, and it supplies all of the tissues and organs with that vital oxygen that is so needed. And then the cycle just repeats over and over again through the vena cava, back through the atria, ventricles, and so on. Since we can't look inside of a human body as this is happening, that's why we have what's called electrocardiogram or an EKG. This is just a picture of the entire process. It's actually an electrical current that's moving through the heart that's making the heart contract and relax. The way that this works is it begins with the SA node. The SA node is the pacemaker of the heart. It sets the beat. It lives in the top of your right atria. The SA node fires and starts the electrical current. It sends its message down to the AV node. The AV node lives in the floor of that right atria. So SA to AV, then it's going to move into the septum of the heart. The septum is that area in between the right and left ventricle. It's going to carry that electrical current down that bundle of His, and then it's going to go up through the Purkinje fibers, which are going to have those ventricles to contract. Like I said, we can't see all of this inside of the body, so we have that EKG. Each part of the EKG corresponds to a part of the cardiac cycle. So the first little hump that you see on an EKG is called a P wave. The P wave is the picture that we see when the atria are contracting. From there, we move on to the QRS complex. It's a much larger section of the EKG, and it's larger because it is the picture that's created when the ventricles contract. Remember, those ventricles are the powerhouse, so it makes sense that that picture would be larger than the P wave. The final picture that you see on the EKG is called a T wave. It's that final little hump. That T wave is just the picture that we see when ventricles are relaxing. To learn more, look for our other videos on medical techniques and procedures.